Climate change is a rampant, ongoing crisis that is plaguing our world. My name is Anthony Rozario, a student from the Department of Geology at St. Xavier's College, Mumbai. And today I'll be talking about a very unique and important method of carbon capture and storage, CCS, in coals. CO2 storage in coal is broadly divided into two parts: CO2 storage in abandoned coal mines and CO2 storage in deep unmineable coal seams. There are various methods in which CO2 can be stored in coal. First of all, CO2 can be stored in the free space present in the abandoned coal mines after all the coal has been excavated. Second, the CO2 could be adsorbed onto the surface area and the internal surface area of the coal via fractures known as cleats, which provide a sort of permeability to the coal. The third is the dissolution of CO2 in mine water and subsequent mineral carbonation that can be occurred from it. Broadly divided into two categories once again, abandoned coal mines and deep unmineable coal seams is in which the storage could be done. Now, abandoned coal mines have a lot more methods, but they have a lot less field tests being conducted on them, and deep unmineable coal seams have a lot more field tests that have been conducted on them. Let's have an in-depth look on the methods coming under both. We start with CO2 storage in abandoned mines in general. Principally, the storage happens in the free space present in the mine after the excavation is done. So, pure CO2 gas can exist in the free space. CO2 could also be stored in the mine water, leftover mine water that is left behind. And CO2 could also be adsorbed onto the coal surface and the internal surface area of the coal. Now, the depth of the mine needs to be around 800 meters or more so that the CO2 is in a dense supercritical state. This allows for better and optimal storage of CO2 in abandoned coal mines. Now, another important factor is that the shafts present in the mine should be sealed well. Any of the shafts that have been used previously. Another factor is a cap rock. The cap rock above the mined coal seam should be impermeable, meaning no gas should be passing through it, and it should be strong so as to hold its own weight even though there is nothing supporting it beneath it. The adsorption of CO2 onto the internal surface area of the coal has a second side effect. CO2 displaces any other gas present in the coal like methane, CH4 or N2. Now, this is because CO2 has the highest susceptibility out of all the gases for adsorption. Due to this, the displaced gases could be extracted for energy production, particularly methane. Abandoned mine globe is a kind of broken rubble that is formed after the collapse of a mine, of an abandoned coal mine. This happens as there is nothing to support the cap rock that is there after the coal has been excavated. There are only coal pillars on the side, residual coal pillars on the side. Now, this fractured zone generates a permeability and a pore space in which CO2 can be stored. CO2 can also be adsorbed onto the remaining coal that is present in the mine and also in the leftover mine water that is present. Now, CO2 storage through acid mine drainage is a unique method in which acid mine drainage is used. Acid mine drainage is a byproduct of coal mining in which the leftover mine water reacts with sulfide minerals to form an acidic drainage. This acidic drainage is harmful to life and needs to be neutralized. For neutralization, lime is commonly used, but it has the side effect of producing sludge due to the formation of gypsum. Now, in order to prevent this and in order to store CO2, CO2 is introduced at the start of the process so that stable mineral carbonates can be formed, particularly calcium carbonate, calcite, and the CO2 could be stored in the mine drainage itself. This is a method of mineral carbonation. Now, CO2 storage for geothermal energy in abandoned coal mines is one of the most out there concepts for it. It utilizes the geothermal gradient of the earth. The geothermal gradient of the earth states that as you go deeper down the earth, the temperature increases. Now, at the start of a mine, let's say a vertical mine, the mine has a lower geothermal gradient. So, the injected CO2 will precipitate out due to the colder environment, and once it precipitates, it sinks down to the bottom of the mine, and due to the higher geothermal gradient present over there, it heats up that precipitated CO2 and makes it into a gas again. The heated up gas rises and goes back into the top of the mine. This creates a convection cycle. Now in between, the energy that is used to heat up the CO2 gas can be used to generate geothermal energy for human consumption. Now CO2 storage in deep unmineable coal seams utilizes the principle of adsorption again. Now methane is the gas that is principally present in most deep unmineable coal seams, particularly bituminous coal seams. Now as methane is displaced by CO2, displaced methane could be extracted and used for energy generation. This method is known as CO2 enhanced coal bed methane recovery. Now the next method is CO2 underground coal gasification. CO2 underground coal gasification is a method of energy generation in which the deep unmineable coal seams that are present are gasified and combusted in order to form energy. Now a CO2 could be used to assist in that process, and CO2 can be stored in the voids that are left behind after the process is done. Some of the CO2 also gets deposited or adsorbed onto the leftover coal present in those voids. Now worldwide, the potential of CO2 storage in coal is around 200 gigatons. For many countries, this is a very viable method of storage as they have many abandoned mine sites as well as deep unmineable coal seams that could be used for this method. The table below summarizes several important early sites that were summarized by IPCC in 2005. India in particular had Cambay Basin and Damodar Basin as important sites for storage. These are some of the field tests conducted all over the world. The majority of the field tests have been conducted by USA on their own soil. There has been a field test conducted in Canada. Most of these field tests have been conducted on deep unmineable coal seams. Only one field test has been done on abandoned coal mine storage of CO2, and that is in Langerlo in Belgium. Now several field tests also have been done in China. 2 have been done, and one has also been done in Japan. In this map, there is also the storage potential of CO2 in deep unmineable coal seams and abandoned coal sites. Now potential in India. India has around 3.7 gigatons of storage for this method, and this method is a very promising means of CCS going forward, and the government of India itself has seen this method along with CO2 enhanced oil recovery as one of the methods it wants to implement going forward under CCS. The table below summarizes some of the promising candidates for CO2 reservoirs in India. It has also divided itself into category of coal beds, in which unmineable coal beds are there, grey areas of storage, and concealed coal fields which are present. Cambay Basin, Damodar Basin, Jharia Basin, and several others are important sites. Now the benefits of this method are several. First of all, it has a good storage potential going forward. It also prevents coal fires that are a particular problem for abandoned coal mine sites. It can also prevent the subsidence of the abandoned mines, like the abandoned gobe that we mentioned, that could be prevented. Now this is because the CO2 is under pressure under there, and it supports the cap rock that is present above the free space that it has occupied. Now a lot of these methods can also be used to generate energy for human consumption, and due to this the costs of injection could be offsetted. There are several drawbacks as well. There could be a leakage of CO2 due to permeable cap rocks, etc. There could be leakage of methane as well that has been displaced due to the presence of CO2 adsorption. And methane is a lot more of a potent gas in short term compared to CO2. Now injected CO2 can also reduce the permeability of deep unmineable coal seams, and this could reduce the coal bed methane that is being pumped out of them. And we also have an incomplete understanding of the adsorption, and more research is required on that. And also groundwater is present in the pore spaces surrounding the mine. It could get affected by the CO2, it could have CO2 dissolved in it, and this could be a potential health hazard for any communities that will utilize that groundwater. Now in conclusion, this is a very effective method of storage, particularly for developing countries and especially for India. A lot more field tests have been done for deep unmineable coal seams than there have been done for abandoned coal mine sites. A lot more research is required and a lot more awareness is required on the topic. In order to increase awareness of this topic and to promote further research, I'd like you to share and like this video as much as possible to increase outreach. These are some of the references that I have used. These are some of the image links that I have used, and thank you for watching.